In this example, we want to analyze this function f of x. We've got a wonderful, nice little logarithmic equation. To do that, we can maybe investigate the asymptotes to begin with. I know we have domain and range listed first, but you don't have to do it in that order. As a matter of fact, if you have another order that works for you that's different than mine, then go ahead and use that order. For me, I like to think about what the graph is going to look like and what I can tell from the equation before I even graph it. And then I like to use the graph to see if that will help me figure out some of the other ones. So the asymptote for this one, definitely going to be a vertical asymptote. We want to look for any shifts left and right, so in the x direction. And there's definitely a shift here, right 3. Oops, right 3. So the asymptote will be x is equal to 3. We can even draw that right here. After we find this out, we're going to look at our points of discontinuity. Well, both exponential and logarithmic, those are continuous curves, so there will be no points of discontinuity. X-intercepts, this graph is going to look something like this, and it's totally going to have a x-intercept. So if we do that work over here on the right hand side, again this is for the x-intercept, all we need to do is just substitute in 0 for y. So we're going to have 0 is equal to log base 2 of x minus 3. If we change this into an exponential, we would have the base 2 to the exponent 0, and then the argument would be over here on the right hand side. 2 to the 0 power, anything to the 0 power is 1, and then all we need to do is just add 3 here, and we'll solve for x. Remember that this is a point though, so if we go back to the left hand side, this x-intercept would be at 4, 0. Remember, we substitute in 0 for y when we're trying to find the x-intercept. So we could actually plot that on the graph. This is a point that totally will exist. It's right there. The y-intercepts, in this case, we could try to solve for y when x is 0. If we look at the function though, we're gonna an x value of 0 is going to produce a negative value here, and 2 raised to any power can't be negative. So that value is not in the domain for this function. There will be no y-intercept. This graph will not hit the y-axis, so we could just write none. For the domain and the range, we come back and do that. We now have kind of a clue what we think this graph might look like. You could graph it now at this point, come back, up to you, whichever one you want to do. For me though, I know right away exactly what's going on after we have our vertical asymptote graph. So the possible values of x would be not including 3, but then all the way to infinity. So we can just write that here, 3 to infinity. Remember to use your parenthesis. We want to indicate that 3 is not a possibility. Algebraically speaking, we can look over here and we can see that this position here, x minus 3, has to be greater than 0. If we solve that, we've got x is greater than 3, which is, in interval notation, 3 to infinity. The range for this one, the possible values of y you can get out, is anything, any real number, negative infinity to infinity. This graph will come from negative infinity, come right up through this point, and keep going on. At this stage, what you can do is make a table of values if you need to, but for what we want to do right now, I'll just go ahead and show you the graph of this thing, and we'll talk about the calculator real quick. And we're going to use this to help us to graph here. This graph on your graphing calculator looks like it stops. I got news for you. It does not stop. It keeps going. As this graph approaches your asymptote, though, the graphing calculator doesn't know what to do. Doesn't know whether to fill in the pixel or not, because the graph shouldn't exist at negative 3, but you're so darn close to it, it just doesn't know what to do with it. And so, for whatever reason, this graphing calculator decides to just kind of leave it off. Please don't get fooled by your calculator. This gives us a good overall picture of what's going on, but there are a great many errors that are inherent in your calculator. that you need to be aware of, and this is just one of them. So when we graph this, we can graph this equation and get real close to that asymptote and then come up to the right hand side. This will help us to do our end behavior. So remember, for our end behavior, we're going to write as x approaches infinity, what does y do? And the value of y, or I guess in this case I could write f of x, try to keep in line with the with what's written previously. So f of x, in this case, as x gets big, this side of the graph, the right side of the graph, keeps on just growing. You can make x as big as you want, and you can make y as big as you want as you continued off to the right hand side. So f of x will approach infinity. As x approaches negative infinity, as x approaches negative infinity, this graph actually will not exist towards negative infinity. So there is no left-hand end behavior. If you want to look at this graph and say as it approaches 3, though, we could say that it approaches negative infinity, but really there is no left-hand end behavior. As x approaches negative infinity, it doesn't exist. So we could just say as x approaches infinity, f of x approaches infinity. So that would be our right-hand side, and our left-hand side does not exist.